These are the answers to the revision fact file questions for 1.8 halogens. So question 1. Which one of the following lists the colour of solid iodine and of iodine dissolved in the solvent stated? So the answer is D. As a solid, it's grey-black. In water, it's yellow-brown, and in hexane, it's purple. The only other possibility could have been A, where the grey-black is correct, and B, the solid is not dark purple or yellow-brown, so that rules out both of those, B and C. In A, then, the colours are the wrong way round, so the answer is D. Next, we have an experiment which was set up to investigate the displacement reactions of the halogens. Solutions of sodium halides were prepared and reacted with other halogens. The results table is shown below. A tick means that a reaction took place, and an X means that no reaction took place. It asks you to complete the 3 remaining spaces in the table. So if we put bromine into sodium iodide, we know that the bromine will displace the iodine. If we put chlorine into sodium bromide, we know it will also displace, it will displace the bromine. But if we put bromine into sodium chloride, the chlorine is more reactive, so we will get no reaction. So there's 1 mark for each of those. Next, both bromine and iodine solutions are coloured. Describe the observations which would indicate a reaction took place when aqueous sodium iodide is added to a bromine solution. So what we're looking for there is that, we're starting with, we're adding aqueous sodium iodide to a bromine solution. So bromine solution is starting as, you could say, yellow or orange or brown. Solution, and it changes to a darker brown. So we've got a yellow, orange, brown solution changes to a darker brown solution. Write the ionic equation for the reaction between bromine solution and aqueous sodium bromide. So bromine solution is Br2, sodium bromide I minus, and that's going to give us the iodine I2 and the bromide ions Br minus. So we need 2 in front of the I minus and 2 in front of the Br minus. Describe what's observed when chlorine solution is added to aqueous sodium bromide. So we're starting here, we're looking for a colourless solution this time. And that it changes to an orange or yellow or brown solution. So chlorine obviously is more reactive than the bromine and displaces it, and that accounts for the colour change. So then write the equation for the reaction between chlorine solution and aqueous sodium bromide. This is not, it doesn't say an ionic equation, it just says the equation. So it's Cl2 plus NaBr, and that's giving us NaCl and Br2. Now we need to balance that, so we need a 2 and a 2 in front of the NaBr and the NaCl. Number 3, the halogens form group 7 of the periodic table. The table gives us some of the physical properties of the halogens. So it says, explain why the atomic radii of the halogens increase as the group is descended, and that's the atomic radius there we can see, and it's increasing as you go down the group. So really all we're looking for here is just to say that as you go down the group, there are more energy levels. Okay. Next is to explain the trend in boiling points of the halogens. So we're going to have to mention van der Waals here and an explanation of why the van der Waals increases as we go down the group. So as you go down the group, there are more electrons. I'm going to fit this in. And that causes the van der Waals to increase. Between the molecules. Okay, next, explain what is meant by the term electronegativity. So you need to learn this definition off word for word. It is the extent to which an atom attracts the bonding electrons in a covalent bond. So the extent to which an atom attracts the bonding electrons in a covalent bond. Part 4, explain the trend in electronegativity values of the halogens. Well, we want to talk about fluorine having the smallest radius. And then, so it has the greatest attraction between its nucleus and the bonding electrons. Okay. Part 5, write the equation including state symbols for the first ionization energy of fluorine. So, well, F gas gives us F plus gas plus an electron. There's 1 mark there for the equation and 1 mark for the state symbols. So that's something to look out for. If the question says include state symbols, you usually get a mark for doing that. Then explain the trend in the ionization energy of the halogens. So we're going to need to talk here about the size of the halogens again. So going down the group, the outer electrons are further from the nucleus. And you also want to mention that there is increased shielding. And that's from the inner electrons. So 1 mark for each of those points there. 1 mark for the outer electrons being further from the nucleus, and the 2nd mark for the increased shielding. Next is about chlorine and water. So they say chlorine is used to sterilize water. Write an equation for the reaction of chlorine with water. So Cl2 plus H2O gives us HOCl and HCl. You keep coming across that reaction. It's in disproportionation, and it also occurs in this topic as well, so best to learn it. So using changes in oxidation number, explain why this is considered to be a disproportionation reaction. So if we look at the Cl2, chlorine in there is 0. In the HOCl, it is +1. And in the HCl, it is -1. And you get 1 mark for all of those oxidation states being correct. And then if you say that chlorine is both oxidized from 0 to +1 and reduced from 0 to -1. That's your second mark. Okay, so that's, you're using the oxidation number, you're stating what they are, and then you're explaining as well. So number 4, solid samples of sodium chloride, sodium bromide and sodium iodide can be distinguished using concentrated sulfuric acid. Write an equation for the reaction of sodium chloride with concentrated sulfuric acid. So we have NaCl, the sodium chloride, and H2SO4. That's 2. And that's going to give us your NaHSO4 and HCl. Then it asks you to balance the following half equation for the reduction of concentrated sulfuric acid to form hydrogen sulfide. And you can see that we've got the sulfuric acid, the hydrogen ion, hydrogen sulfide and water, but there's a gap because there's something missing on the left hand side. And what's actually missing is the electrons, but if we balance it up first, we have 4 water and 8 hydrogen ions, and then we need 8 electrons. So combine the reduction half equation with the following half equation to produce a balanced redox reaction. So we need to multiply this one by 4 because we have 8 electrons here and 2 electrons here. So to make sure the same number of electrons are in both, we're multiplying the second equation by 4. So we end up here with 8I minus plus 8H plus H2SO4, and that is giving us 4I2 plus H2S plus our 4 water. Okay, part 4, give one observation which indicates the formation of hydrogen sulfide. Hydrogen sulfide, rotten egg gas, so it's the rotten egg smell. Name 2 other reduction products that are formed when concentrated sulfuric acid is added to sodium iodide. So we're looking for 2, so make sure you write 2. The first one is, of course, sulfur. And the second is sulfur dioxide. And it says, suggest why iodide ions are stronger reducing agents than chloride ions. So if they're reducing agents, they cause other things to be, to react. So, the outer electrons in the iodide are further from the nucleus, or they're more shielded. That's the first thing we're going to say. So the outer electrons are further from the nucleus than the iodide ions. So iodide ions sorry, I can't write at the minute. Iodide ions lose electrons more easily. than the chloride ions. And finally, number 5, which one of the following increases as group 7 is descended? Well, the answer is A. You can see that straight away. It's atomic radius. B is electronegativity. Obviously, it increases up the group towards fluorine first. Ionization energy increases up the group, and reactivity also increases up the group. So it has to be A.